Hello students, in the last part we discussed some questions based on the concepts of trigonometric equations. In this part also I will be having some more complex questions based on those concepts. So let's start.
Coming to the next example, that is cot of sin x plus 3 is equal to 1. We have to find the value of x. Now this was the question in IIT-JEE in the year 2000. Now that seems to be a bit confusing. How can I have sin x within the bracket as an argument? But if I apply the limits, I'll be able to solve this question also. So that is cot of, let this be just any value alpha. So cot of alpha is equal to 1 just for the instance. So cot of alpha is equal to 1. So I would get alpha which is equal to sin x plus 3 being equal to n pi plus pi by 4, as this is equal to cot pi by 4, and if I take a reciprocal on both the sides, that would give me tan of sin x plus 3 being equal to tan of pi by 4. I can write it as a solution, sin x plus 3 is equal to n pi plus pi by 4. That's what I have written here. Now if I see this and this term, the next logic I will have to apply here. Sin x lies between plus minus 1. So sin x plus 3 shall lie between 2 and 4. Hence, n pi plus pi by 4 shall also lie between 4 and 2. Because they both are equal. So applying a limit to 1 would give me solution for the solution of limit range for the second, and hence I can deduce that the value of n here, all of them are in radians. So that is 2 radians, that is 4 radians, and the value shall lie in the middle, that is between 2 and 4. So only for the value of n equal to 1, this equation shall be valid, both the inequalities shall be valid. That is, I would get sin x plus 3 is equal to pi plus pi by 4, which instead is equal to 5 pi by 4. I would get sin x as 5 pi by 4 minus 3, or x would be written as, now this is the base angle, that can be written as sin inverse 5 pi by 4 minus 3. Now for the general solution, I would get x as it was in terms of sine, so I would get x as n pi plus minus 1 raised to n alpha. Now here alpha is the base angle, that is sin inverse 5 pi by 4 minus 3. This is the base angle. Moving on to the next question. The example here says, find all the acute angles. Acute angles means that alpha shall lie between 0 and pi by 2. That is first quadrant itself. I have not even read the whole question. I have already reduced my area of my region of solution. So I would get, if I have I have to find the acute angle alpha such that cos alpha, cos 2 alpha, cos 4 alpha is equal to 1 by 8. Now let's figure out how we can proceed with this question. I just rewrite the equation that I am given. That is cos alpha, cos 2 alpha, cos 4 alpha is equal to 1 by 8. I'll multiply sin alpha on both the sides. Reason being, you'll just get to know I get sin alpha, cos 2 alpha, cos 4 alpha is equal to 1 by 8 into sin alpha. Here I get sin 2 alpha, cos 2 alpha by 2, that is sin alpha cos alpha is equal to sin 2 alpha by 2 into cos 2 alpha cos 4 alpha as it is. Then on the right hand side I have sin alpha over 8. 2 and 8 cancel out. So I get now sin 2 alpha and cos 2 alpha is sin of 4 alpha by 2 into cos 4 alpha as it is and sin alpha over 4. Again 2 and 4 cancel out, giving sin 4 alpha cos 4 alpha is equal to sin alpha by 2. Now sin 4 alpha cos 4 alpha is equal to sin of 8 alpha over 2, which is instead equal to sin alpha over 2. 2 and 2 cancel out, giving me sin of 8 alpha minus sin of alpha being equal to 0. If I apply C and D formula into this, I will apply C and D formula, that is the sum or the difference form can be written in terms of the product form. So I would get 2 cos C plus D by 2. Here it is of the form of sin C minus sin D, which can be written as 2 cos C plus D by 2 sin C minus D by 2. This will be applied here, and hence I would get 2 cos 8 plus 1, that is 9 alpha by 2 into sin of 8 minus 1, that is 7 alpha over 2 being equal to 0. So either cos of 9 alpha by 2 is equal to 0 or sin of 7 alpha is equal to 0. That gives me either 9 alpha by 2 is equal to 2n plus 1 pi by 2 or 7 alpha by 2 is equal to n pi. That gives me alpha being either equal to 2n plus 1 pi by 9 or alpha is equal to 2 by 7 n pi. Now I'll write down the values of the probable values of alpha, and that those values should be less than 90 degrees or should be the acute angles. So for n is equal to 0, the values are pi by 9, and for n is equal to 1, I get pi by 3. For n is equal to 2, I get 5 pi by 9, which is more than pi by 2. Hence, for first it's just the two values. For the second, I can have, when n is equal to 1, I will have 2 pi by 7. For the next, I'll have 4 pi by 7. Now 4 pi by 7 is greater than pi by 2, hence it can be included. So, but just this. So these will be the solutions. Moving on to the next part. Next part says log of base sin square x of 2 plus log base cos square x of 2 plus 2 log base sin square x 2 into log base cos square x into of 2 is equal to 0. This was in JEE 2000. So we'll see how we can solve this. It needs some basic logarithm properties to be applied. So we'll have log of base. Now see, there's one property, that is log base a of b can be written as 1 by log base b of a. So I'll apply that property here. I'll get log 1 over log base 2 of sine square x plus 1 over log base 2 of cos square x plus 2 over log base 2 of sine square x into log base 2 of cos square x is equal to 0. Taking LCM, I get log base 2 of sine square x into log base 2 of cos square x is equal to 0. In the numerator, I get log base 2 of cos square x plus log base 2 of sine square x plus 2 is equal to 0. So only the numerator part would be equated to 0, and I get log base 2 of cos square x into sine square x plus 2 equated to 0. I get log base 2 of cos square x sine square x being equal to minus 2, or 2 raised to the power of minus 2 is equal to cos square x sine square x, which can be further written as sine square 2x over 4 is equal to 1 over 4. That gives me sine square 2x equal to 1. Or now this is of the form of sine square theta is equal to sine square alpha, solution to which was n pi plus minus alpha. So I'll write it down as sine square pi by 2, and hence the solution to this equation would be written as 2x is equal to n pi plus minus pi by 2, or x is equal to n pi by 2 plus minus pi by 4. As sine square theta plus is equal to sine square alpha, the solution was theta is equal to 2n pi plus minus alpha. So this is applied, and hence we get this solution.
So students, in this part we discussed the type of questions based on these concepts involving trigonometric equations like the unit circle, general solutions, principal solutions. I hope you must be having a good command over these concepts. Now let's proceed to the next level of this chapter, which involves the type of questions that can be framed from this. I'll be discussing the type of questions. In the next part, we'll be having the two types which involve by factorization and by introduction of auxiliary argument. Stay tuned.